Welcome. Today, we're going to continue our integration testing into your development flow. Specifically, today, we're going to be talking about continuing our discussion, actually, with our hands-on with TestNG. Specifically, our topic's going to be looking at the reporting side in TestNG. In the previous two presentations, we've discussed what TestNG is and have gone through a complete walkthrough of where to get the tools, setting up your environment, the different annotations you can use, how to execute your procedures, execute your tests, looking at the different types of suite testings you can do, how we can ignore a test, group testings. Last time we talked about exception testing, dependency testing, parameterized testing, and we also looked at how we can actually run our old JUnit test within TestNG. Now, before we get into today's topic, we've actually been looking at TestNG reporting throughout our presentation, but at the very basic level. So here we kind of looked briefly at the HTML that gets generated when we run our test scripts. To the right is our little dashboard we get within the TestNG Eclipse plugin. And down here at the console is what we would see if we run our TestNG tests at the command line. So we are seeing some reporting as we're actually have been using the TestNG tool all this time. We just haven't really delved into the specifics of reporting. We've just been using the out-of-box testing. So today we are going to look at how we can expand on these to add more meaningful logging and reporting to our test suite. After all, isn't reporting one of the most important parts of any test execution? Without it, how would you begin to understand and decipher the results of the test execution, identify points of failure, and determine the cause of the failure? Whereas logging is important for determining the execution flow or for debugging in cases of failure. So today we're going to start by reviewing the reporting features of TestNG. These include reporters and listeners. Reporters, for implementing a reporting class, the class has to implement a iReporter interface. These classes are called when the whole suite finishes. So this is at the very end of the test, your whole test suite. The object containing the information of the whole test run is passed to this class when called. Listeners, for implementing a listener class, the class has to implement the iTestListener interface. These classes are notified at runtime by TestNG when the test starts, fails, finishes, skips, or passes. Underneath the listeners, here's just a list of some of the types of the TestNG listeners available. This is not the complete list, but this is some of the most important ones that we'll be looking at today. These interfaces are used to generate logs or customize the TestNG reports. The iAnnotation transformer, TestNG allows you to modify the contents of all the annotations at runtime. This is especially useful if the annotation is the source code are right most of the time. But there are a few situations where you'd like to override their values in order to achieve this. You need to use the annotation transformer. However, the iAnnotation transformer interface only lets you modify a single test annotation at a time. If you need to modify other TestNG annotations, a configuration annotation of factory or data provider, you would want to use the iAnnotation transformer too. iHookable. TestNG allows you to override and possibly skip the invocation of test methods. One example of where this is useful is if you need to execute your test methods with a specific security manager. You achieve this by providing a listener that implements iHookable. iInvoked method listener. The iInvoked method listener allows you to be notified whenever TestNG is about to invoke a test annotated with the test annotation or configuration annotated with any of the before or after annotation methods. iMethod interceptor. Once TestNG has calculated in what order the test methods will be invoked, these methods are split into two specific groups: methods that run sequentially and methods run in no particular order. The methods that are run sequentially, these are all the test methods that have dependencies or dependents. These methods will run in a specific order. Whereas the methods with no particular order, these are all the methods that don't belong in the first category. The order in which these test methods are run is random and can vary from one run to the next. although by default, TestNG will try to group these test methods by class. The list of methods that are passed in a parameterized are all the methods that can be run in any order. Your intercept method is expected to return a similar list of iMethod instances, which can be either one of the following: the same list you received in parameter, but in a different order, the same list of iMethod instances objects, a bigger list of method instance objects. Next, we have iReporter. The iReporter interface only has one method, which is generateReport, that takes two parameters. It takes a list of iSuite and a string for an output directory where you would want to store your report. This method will be invoked by TestNG when all suites have been run, and you can inspect its parameters to access all the information on the run that was just completed. Unfortunately, this method can cause some memory issues when dealing with larger test cases or data sets. Bear in mind that iReporter gets executed when your test suite's finished, so it has all that test information stored in memory. So if you have hundreds and thousands of tests and you try to run them in one particular test suite, you potentially can run into memory issues. iSuite Listener. iSuite Listener is used when you would like to perform a specific operation before or after the test suite invocation is performed. So before TestNG picks up your suite for execution, it makes a call to the onStart method and runs whatever has been scripted in this method. In a similar way, it again makes a call to onFinish method after the suite has been run. This listener does not affect any tags and methods. It runs onSuiteStart and end before and after any tags and methods have been reached. The listener is called for each suite. If the parent suite contains children's suites, then the children's suites are run before running the parent suite. This is done so that the results for the parent suite can reflect the combined results of the children's suite. iTestListener. If you like to perform specific operations when a test is skipped, fails, passes, or maybe you'd like to perform a step before test invocation is ever performed. So before TestNG picks up the test for execution, it first makes a call to the onStart method and runs whatever has been scripted in this method. In a similar way, it does the same thing for onFinish method after the test has been run. Some of the other methods, though, inside of iTestListener are onTestSuccess, onTestFailure, onTestSkip, and onTestFailed, but within a success percentage. Now, unlike the other three, which are pretty straightforward, these are methods that are called when a test passes, fails, or skips. The fourth one, onTestFailed, but within success percentages, these are methods that is called each time a test fails, but is within a success percentage. So if you're trying to test for tests that fail with 10% of the time, 1% of the time, or you want to actually set up a expected pass-fail percentage, you can specify that within this iTestListener. Today, we're going to do a hands-on of some use cases. We're going to look at creating some custom logging at the command line logger. We're going to look at some custom reporting for additional reports, HTML, things of that nature, and XML reports. And we're also going to look at JUnit reports. So I'm going to jump out of the presentation now, and we are going to actually get our hands dirty with this. So again, I'm going to continue to use Eclipse. I use the STS Eclipse build because I like a lot of the plugins that Spring provides with their Eclipse. I also have already pre-installed the TestNG plugin, so I have my nice little GUI here to look at how the tests pass and fail. I like Maven projects, so I'm going to create a new Maven project. And the reason I like Maven is because it's very easy to maintain all your dependencies with the POM file, keep things clean. Default location, there we go. There. All right, so group ID. And object ID, this one will be green. Oh, that's good. Finish. There we go. We now have our Maven project. We have our main resources, test resources, everything we need. The only thing we're missing from our project is we need to actually include on the build path, we need to add a TestNG library. This way we can run all of our tests with the Eclipse plugin. Dependencies, that guy should be, nope, I want 1.8. There we go. And we don't need these two because we're not going to be doing anything with maybe annotations. Warnings went away, everything's good. All right, so the first thing we're going to do is we're going to create a custom logging test case. So we're going to need to create 3 files, 2 classes. We're going to need to create a custom logging test, and we're going to need to create a custom logging listener. We will also need to create our XML file with our TestNG script in order to run these tests. So the first thing we're going to do is we're going to create our class. This is going to be custom logging test. Get my cheat sheet here so we don't have to sit here and watch me type everything. All right, so we have our custom logging test. I've created 3 tests in here with the test annotations. I've set the priorities so that they'll run in order. So we have test method 1, test method 2, and then our third test method actually depends on test method 2 passing. So the way this is currently set up, only test 1 and 2 will run. So we'll just run this guy without doing anything additional at the moment. And we see here, we have 1 that passed, 1 that failed, 1 that skipped. And down here in our logs, it says the same thing. We ran 3 tests, 1 passed, 1 failed, 1 skipped. So this is the default logging that we already get. So here we have test passed, test 1, failed, test 2. Here's why it failed. And then we have test 3 skipped, and here's why it failed. So nothing new. This is what we've seen before, and this is what we're expecting. All right, next we want to create a listener class. We will call this one custom logging listener. And this class must implement the iTest listener. So parent interface iTest listener finish. And in this listener, we're going to include methods for onTest fail, onTest skipped, and onTest successful. And then we're going to use the iTestResults.getName method to get the test method name for logging and add some simple system.outs for console logging as well. So let me copy that. Just do it here. Oops. There we go. All right, so we have iTest listener interface. So our interface contains multiple methods, but because they're all default voids, we don't have to override. We just have to include them when we want to actually use them. And the 3 we want to override are going to be the onTest fail, onTest skipped, and onTest successful. And all we're going to do right now is we're actually going to get the test name and right out to the command line failed, skipped, and success. Next, we need to create our XML file. And this guy we will call custom logging TestNG XML. And in here we have our XML declaration telling the system that it's an XML file. We're specifying the document type is going to be our TestNG test file. Our suite, all TestNG XML files start out with the suite. And within the suite, we have a grouping of tests. And you can also add a grouping of listeners. So this guy is new. We have not used listeners to this point. We can stick a reporter or our listeners at this level. And if we're using iTest listener, we can capture the onTest success, fail, onTest start, finish. So we can actually listen to the test or do things with the test as the test run. If we do the reporter, we have to wait till the test finish or the suite finishes in order for us to do anything. So you can actually specify multiple listeners. So you can actually have an iTest listener that actually does things as the tests are running, and then you could actually have a reporter as well slapped in here. And then we can add our tests in here. Now, the reason the reporting is set up where it's talking about subsuites is you can actually fragment this file here and actually call subsuites as well. So you would actually have a suites in here. So you can create a set of suite files and then essentially have what you have here and then point to them at this level. But typically you want your listeners to be at the master suite level. All right, we have our custom log testing, and then we have our log testing, which is just going to be in log testing. Another reason why I like using Eclipse, because if you have messed up your path information, if you hold the control key, it will tell you if you can actually, if it can find the file or if it can't find the file. So if it can find it, it'll be underlined, and it'll let you jump to it. If it couldn't find it, it wouldn't be underlined like it was before. My previous example, I had a class path in there. All right, now if we right click on this guy, we can now run him, TestNG. And as you can see, our reporter looks different now. We now have test method 1, test method successful, test method 2, test method fail, test method 3, test method skipped. And then we have the custom logger suite was run. Now, if I ran that directly without the listener, it gives us the default reporting. So as you can see, we were able to override the reporting using the iTest listener. So we've actually overridden the logging. Now, while we're running all this, it's actually generating some additional test code behind the scenes, and we'll get to that in just a minute. So next, we're going to create a custom reporting test case. So now we need to create another listener. So we're going to reuse our custom logging test, but we're going to create a new custom reporter. So this is going to be reporter, and he needs to implement iReporter. There we go. So this method must implement iReporter. We're going to add some simple system.outs for logging again, like we did with the iTest listener. Let's see, we're going to, so the preceding class implements the iReporter interface. It implements the definition for the method generate report of the iReporter interface. The method takes 3 arguments. So we have our XML suite, which is the list of suites mentioned in the TestNG XML being executed. The suite, which contains the suite information after the test execution. This object contains all the information about the packages, classes, test methods, and their test execution results. And we also have the output directory parameter, which contains the information of the output folder path where the reports will be generated. And we're also going to create another test suite XML called custom reporter TestNG. And this will add the listener custom reporter inside of our listener tag. And then we're going to, again, reuse the test tag and set the parallel flag to false so that we don't run it in unison. XML file. So again, we've got our listener and we have our test, we have our suite, and we're going to do our custom reporter test. But we're actually calling the custom logging test. So that was right. But we're actually calling the customer reporter suite now, not the custom logger suite. And I need to remove my path information from my previous example. And hold the command key, make sure everything's there. It is. Great. So again, if we run the custom logger test directly without overriding the reporting, this is what we get. If we now run the custom reporter, we get our clean reporting. So we have total passed tests for suite. Custom reporter suite is 1, failed, skipped, 1 and 1. And as you can see here, that's what we also get in our TestNG plugin. We have 1 passed, 1 failed, 1 skipped. All right, next, let's look at creating a custom HTML and XML report test case. So TestNG comes with certain predefined listeners as part of the library. These listeners are by default added to any test execution and generate different XML and HTML reports for any test execution. The report is generated by default under the folder name test output and can be changed to any other folder by configuring it. These reports consist of certain HTML and XML reports that are TestNG specific. So let me rerun just our straight up custom logging test. And now if we go back over to our project and refresh, we have a test output folder. Inside of our test output folder, we have folders for each of the tests that we ran. So you have custom logger suite, custom reporter suite, our default suite, JUnit report. So you have your specific JUnit testing. So you can actually pull it up in the plugin and actually view it that way. Default suite, custom reporter suite. And then if you come down here to the index.html, open it with our browser, it generated all this wonderful code for you behind the scenes. So you now have links to all your tests. So here's your reporter, here's how many times it ran, how long it took to run, what failed, what skipped. And out of the box, this is pretty detailed information. But as you can see, if you have lots of tests, this is a lot of code that will get generated behind the scenes, and it can take a lot of memory. So you got to be a little careful with how much disk space you have for logging and how big your tests are for running your reports. So now we're going to create a custom reporter 2 class that is going to create a custom HTML report. We're also going to create another custom logger. So our logger report will actually be modified as well. And we're going to create another test suite HTML XML reporter file. So we're going to create a new test. So we're going to create a new reporter called custom reporter 2. This guy is going to do iReporter. And he's going to be pretty massive, so it'll take us a minute to walk through this guy. All right, so we're overriding the generate report method. So if we look at the declaration of iReporter, the only method it has is generate report. It takes a list of XML suites. Within that, you get a list of suites, and then you have the output directory. Go back to this guy. The first thing I wanted to do was I wanted to create a string builder so I can store all my HTML strings into one string builder file and at the end dump it out to a file. String builder is more memory safe when you're dealing with appending of a lot of strings, especially for files. So I have a new file, output directory, make directory. So if our output directory doesn't exist, we'll create our directory. I created a write to file, which uses the Java 8 files class, write, path to get output file, and then the text I use get byte. Within here, we're passing the output directory, which does not include the hyphen. So if you actually just tried to concatenate these together, you would get a file name with the output directory custom report. We don't want that. We want it to actually be stored in our test output file, which is our test output folder, which is our default. But we do want to create a custom report HTML. And we're going to pass in our string builder to string. Now, if we do get an IO exception, we do want to report it. So error rating, we should not get that in this case. I also created some support methods, print, so I don't have to write system.out print everywhere, pass in the line text that I want to actually be printed out at my console. I created some just standard HTML methods so I don't have to copy, paste, change anything. And this will be a good example for you once I upload it to the site so that you can actually go in and kind of use this and tweak this for your reporting needs. Just kind of a quick start. So just some predefined HTML methods here. Add table rows. So instead of having to actually create TDs and table rows, I set it up to where I could pass a string array, and then it would loop through the string array and add all the columns I needed to add to my table. So as you can see here, here's my formatting. So all the string builders are building my HTML file, and all my prints are actually writing out to the console. First thing we do is we get the suites. So the suites comes from the list of iSuites. So this takes the XML file and it goes through and it grabs all the suites within your current XML and any children's suites that you have, so that we can then loop through all of the individual test suites to run them. Next, we loop through all the tests within the suite, and within the tests, we get the test failures, we get the tests that have passed, and we get the tests that have skipped. I'm essentially just overriding this clean report that they have and making something similar, but I kind of wanted to give you guys all the functionality that you could actually do. Some other things you can do within each of the context. So within the test context of the actual test, you can get the report directory, the test suite name, the start and end date, execution time, get name. You can get the host. There's a whole slew of information you can actually get here, which is really useful. Something else that you could do within here that is a little more of an advanced topic, I'm not going to get into too much today, but you can actually inject results from one test and push them into another test. You'd have to use the context and you would have to actually assign some variables in memory, but using the listeners is how you actually do this. So if you actually had to create multiple test cases for, say, a user role, you could actually define a sequence ID and pass the sequence ID in memory for whichever test cases you want to pass their result values around for corresponding children's suites. Again, that's more advanced topics, but I did want to throw that out there so that you know that you could do that here. So let's see, within here, so we're going to our test suite. So within our test suite, we can get the context, we get the name, then we can get the result map. So I can say test context get the failed, I can get pass test, and then within each of those, I have another set of iTest results, which I can then loop through to get the information of the individual test. So again, test results get name, get throwable. If for the failed, for the pass, you can get start time, end time, same context that you have up here. And I'm building a table for each of these. I'm again writing out to the logger for each of these. So we'll save this guy. And then I want to create another logger, another test suite XML. Finish. Now this guy's going to point to our custom reporter 2. And again, we're going to reuse the custom logging test. If I run this guy, oops, can't find /logger. There we go. Now it should run. There we go. So at my console, here's my log report I created. So total test suites 1. Here's the suite name. Here's the test name. I had one test fail, and here's why it failed. I have one test that passed. Here's how long it took to run, and then we skipped one. Now, if I go look at the HTML XML, so refresh my test output. Here's my custom report. Open that with a browser. And it's just a pretty simple report, but I wanted to show you that you can actually create your HTML any way you want. So I have total suites run 1, the suite name, the test suite name, and the results of the test suite. And each of these are actually in a table right here. So there's the method, test name, and the results. Now, just to see that this isn't hard-coded, we'll actually come up here to the logger test. I will turn off the dependency, and I will let this one fail. And I'll rerun my test. Test 1 passed, 2 and 3 failed. And as you can see, because I dropped the priority, test 3 ran whenever it felt like it, but 2 did run after 1. I look at my reporting. It's the old report. Here we are. So we had 2 test methods fail, 1 pass. Now, if I actually run the custom report, there we go. I have 2 fail, 1 pass. Look at our custom logging. We have 2 failed, 1 pass, no skipped. And now let's look at our custom report. And there we go. We have failed count 2, and there's our results. Okay. Next, we're going to look at JUnit report test case. So to generate your JUnit report, you actually don't have to do anything within your test cases or your TestNG XML. Once you actually have something in your test output, you can create a Ant script that will generate JUnit reports off of your logs. So we want to create a new file. This is going to be build.xml. So JUnit is one of those unit frameworks which were initially used by many Java applications as a unit test framework. And by default, JUnit tests generate simple report XML files for its test execution. These XML files can be used to generate any custom reports as per testing requirements. We can also generate HTML reports using the XML files. Ant has such a utility tasks which takes these JUnit XML files as input and generates an HTML report. TestNG by default generates XML reports for any test execution in the test output folder. We can use these XML report files as input for generating a JUnit HTML report. So let's take an example. Now that we have our JUnit XML reports available from the last test case, let's create a simple Ant build configuration, which we have here, to generate an HTML report for the test execution. The XML in the build XML defines a simple Ant file having a specific Ant target name, JUnit-report, that generates a JUnit report when executed. The target looks for the JUnit report XML files under the directory test-output/JUnit reports. For the Ant configuration file, the default target to execute is configured as JUnit-report. Once executed, a JUnit HTML report will be generated in the configured directory /HTML-report/JUnit. We'll open the file name JUnit-noframes.html on the default web browser once we run this. So let's run this guy as an Ant build. And you can see here, it made the directory HTML reports. It then made the report directory JUnit. And then it found the test suite XML, that from the JUnit reports, and it loaded it. So now if we expand on this, refresh, there we go. HTML-reports. Here's our JUnit reports. And here's our JUnit with no frames. Web browser. And here's our nice summary, JUnit summary report. And as you can see, it's a lot different than the TestNG. It's all extracted to one page, pretty clean cut, which is actually good for emailing. You need to send an email file to like your managers or something. This is pretty straightforward. So just something that you can do with JUnit. And then if you have any JUnit CSS or configuration that you have from your old JUnit test results, you could export your TestNG reports to your JUnit folder and use your JUnit templates from your previous projects, and then you don't essentially have to rebuild your reporting. So here we have seen how to use the JUnit XML report generator by TestNG and generate the HTML reports using ANT. There are two kinds of reports that can be generated using this method, though. There's the frames and no frames. So if the report generation is configured with frames, there'll be multiple files generated for each class, and the main report will connect to all of them through the links, similar to TestNG. A no-frame report consists of a single file with all the results of the test execution. This can be configured by providing the respective value to the format attribute of the report task in ANT, right here. New frames or no frames. We run the build. Refresh. And as you can see, we now have all of our HTML files. And we start with index. And there we go. So you can click your failed. Which this is nice for navigation, but it's lousy for essentially email reporting, because then you have to package all this up and send it. So at this point, does anyone have any questions?
Hey, Michael, I was going to ask if you could give a little insight, and forgive me if this is if this is the wrong question to ask, but like the insight between JUnit and this TestNG. I realize I've not really just looked into JUnit's ability to do reporting, so that's definitely a difference. But could you give some insight into that? And then the second question would be, as opposed to using the interfaces, using annotations, have they gone that route with TestNG? I know Spring is doing a lot of stuff where they're eliminating the interfaces in favor for the annotation.
The answer to your first question, if you actually go back to the first lesson of this, I covered that pretty in depth in that lesson. So I don't necessarily want to recap that one now. But as for the second one, the annotations are used pretty heavily within TestNG, but the interfaces are mandatory if you for the listener classes. Because with your listeners, you want to be able to override or essentially capture what you want to do within the listener class. Now, there are annotations. You can add them throughout. It just tends to not be as clean, because if you add them within your test classes or you add them within your test suite classes, you then have to dig through your code and find, oh, where did I annotate that? You can do that. And with the listeners, it does work that way, but that's kind of more of an advanced topic to get into, which we'll discuss more of that later.
Gotcha. Yeah, I actually saw just some slight behavioral differences between the annotated methods versus just the contracted methods from the interface. So it's really caveated. I understand that. Yeah.
Well, and the trick is the annotations can essentially replace some of the configuration you have within the TestNG XML file. But if you do that, then how are you going to know what listeners are actually being implemented?
That's good. Yeah.
So a lot of the stuff I do with the XML files, I know a lot of people don't like using those, and you can create configuration files and move it to Java code. That's fine. But when you're dealing with multiple frameworks and potentially even multiple environments, the XML files or the config files that you could create at the command line allow you to actually create custom environment configurations. Now, you could code that, but say your environment changes. Well, then you got to go back into the code. Then you got to compile the code. Then you got to deploy the code. Whereas if it's just an XML file, all you have to do is go copy it to a different machine and change your configuration, and you're done. No compile necessary. So it's one of the big trade-offs you have to watch when you do things like that.
Yeah. Well, that's good insight. Thank you.
You're welcome. So to review, today we looked at how to expand on the reporting and logging tools provided by TestNG to add more meaningful logging and reporting to our test suite. We looked at several examples of how to write your own custom logger and reporters. We also looked at how to generate HTML and XML reports when we run our test cases to see how TestNG actually creates the existing ones within the framework, and then how to modify those and create our own. And finally, we looked at how to generate JUnit reports in TestNG so that we can reuse some of our old JUnit reporting configurations that we may have had pre-existing from older projects.
Thank you. We know your time is important, and if you would like to discuss any additional questions or comments you have, you can check us out on info@developer.nerd.com. You can check us out on developer.nerd.com/contact us. We're on Twitter @developer.nerd, and we're also on facebook.com @developer.nerd. Our goal is making every developer better, so please check us out, ask us questions, and check out some of our other videos.